This is the first in a series of videos on the subject of configuration management, designed to provide a grounding in the subject, and to also allow those of you who are either about to start doing development or have recently started to understand what it's all about and how important it can be to projects. Firstly, let's explain just what configuration management actually is. Configuration management, CM, is a disciplined practice for establishing and maintaining the consistency of a system's functional and physical attributes throughout its life cycle. It does this by identifying every component that makes up an environment: source code, libraries, binaries, configuration files, data schemas, hardware settings, network topologies, and even cloud service definitions, and recording each item's version, relationships, and dependencies in a controlled repository. Whenever a change is proposed, CM tools such as version control systems, build pipelines, and infrastructure as code platforms enforces a defined process that captures who made the change, why it was made, and what impact it may have, while automatically validating that the new state remains compatible with the rest of the system. The primary goal of CM is to ensure that a system can be reliably reproduced, audited, and rolled back at any point in time. By keeping a single source of truth and automating the propagation of approved changes across development, testing, staging, and production environments, CM eliminates "it works on my machine" problems, reduces unplanned downtime, and provides the traceability required for security, compliance, and quality assurance initiatives. In essence, configuration management turns a complex, ever-changing collection of assets into a manageable, predictable, and auditable foundation for delivering reliable software and services. This all sounds great when you have a fully set up system. But where do you start? Let us for the moment assume that you've been called into a conference room with a number of other staff, some of whom you know and some you have never met. The speaker tells you that you are to become a team developing a brand new product, something that the organisation hasn't done before. During a development career, you may work on a number of these new projects, but a lot of your time will be spent supporting, fixing, or enhancing existing products. So any chance of working on something brand new is always an opportunity to learn new things and try out new technologies. If you are working for a software house, they will undoubtedly have processes to handle setting up a new project. But let's assume for the moment that your organisation is at the start of the software journey and is starting with a blank sheet. Where do we begin? If you are lucky enough to be involved from the very beginning of a new project, you may well get involved in the requirement. This is where what the software is going to do is specified. If your organisation has been contracted to build this new product for another organisation, then there may already be a customer requirement detailing what this new product is actually to do. This requirement should be considered like a blueprint for the product and should specify every aspect of what it will do and what dependencies it has. The detail of the requirement is what your new product will be tested against. It's very counterproductive to skip the requirement and just bash on with the coding and build a product. As any experienced testing team will confirm, they have to test the product against something. If there is no requirement, how can they confirm that it is performing correctly? The very last thing you want is a verbal requirement. Of course, your team needs to be prepared for the requirement to evolve during the project. Often, the first build of a project, when shown to the customer, triggers additional requests for change that they will want added to the project, Controlling this enthusiasm is the job of the project manager, as any changes may very well impact the timescale for finishing the project. So what do you do with this list of requirements that exist in the requirements documentation? You'll find that having a series of configuration management tools is essential, and the first of these is a system to hold these requirements at a fairly low level and any subsequent change requests. This may well be a dedicated requirements management system or an issue management system, depending on which set of tools you will be using. This is basically a database of the to-do list for the project, held in separate entries, which are numbered and have each an associated state. These atomic level entries will go through this workflow of states as they are developed, starting off with proposed and going through planning, in development, peer review, and completed development, and also a range of testing states before being marked for release. Some workflows may also have on-hold states where an entry can be parked awaiting something else being completed. Such workflows may vary slightly from project to project. Once the development team has had a chance to read through and understand the requirement, these requirement entries may be separated into logical groups to reflect those associated with each other and to allow the project to go through a number of phases. You may, for example, divide the project into 10 phases, with a working product, albeit with limited functionality, being delivered to the customer at the end of each phase for their feedback. This feedback may require additional entries to be added onto the to-do list in the issue or requirements management system. This will become part of the work for the next or subsequent phases. So now we have a process to gather and maintain changes to requirements for our new product. The next step is to look to the architecture of the product, which we'll cover in the next video. That's it for today. Thank you for watching.
Thank you for watching today's video. Please feel free to click on the link in the description below to discover more videos.